Hey y'all, in our final lesson, we are going to be looking at using operations, addition, subtraction, and multiplication and division with numbers in scientific notation. So we want to be able to perform these operations with numbers already in scientific notation. Our essential question for the whole lesson is, how does using scientific notation help when computing very large or very small numbers? In this first part of the lesson, we're going to look at addition and subtraction. To add or subtract, numbers must have the same power of 10. We will often need to rewrite our answer so it is in proper scientific notation. So two big things. We need to have the same power of 10, and then know that we may need to rewrite our final answer into proper scientific notation. Let's look at example 1. Example 1, adding two numbers in scientific notation and express your answer in scientific notation. 8.8 times 10 to the power of 7 plus 3.1 times 10 to the power of 8. Now, right off, these do not have the same power of 10. So we need to make them have the same power of 10. We can't make a power of 10 larger, so we can't change 7 to 8, but we can make the 8 and change it down to 7. We do this by taking out a 10, and then that goes from 8 down 1 to 7. So we are rewriting here, 10 to the 8th power as 10 to the 7th times 10. Once we do that, now we can rearrange so that both have the 10 to the 7 at the end. So you see we just kind of switched these two here so that the 10 to the 7 is at the end. Then we can kind of regroup. The 10 to the 7 is part of both of these, so we can do 8.8 plus 3.1 times 10, all to the power of 10 to the 7th. 3.1 times 10 is just 31. We just moved the decimal over one place. Then we have 8.8 plus 31, which is 39.8. So now we have actually added. However, this is not proper scientific notation because 39.8 is a larger than 10. Okay? So we want to move that decimal back over, so we have 3.98, and when we move it over, we have to add 1 back to the exponent. So the exponent will go back up to 8. So kind of to sum that up, we're going to make them both be the same. Then we're going to factor out the same power of 10 and do some multiplying and add, and then rewrite in proper scientific notation. Let's take a look at a problem that involves subtraction. The mass of the Earth and the mass of the Moon are shown. So we have the mass of the Moon is 7.35 times 10 to the 22nd kilograms, and the mass of Earth is 5.97 times 10 to the 24th kilograms. How much greater is the mass of Earth than that of the Moon? When someone asks how much greater, we're looking at a subtraction problem. We'll want to subtract the two values, but we can't just subtract the first part of the number, right? As we saw in that last example, we have to have the same power of 10, so we can't just go subtracting. One way is to rewrite these in standard form and then subtract them. Earth's mass in standard form will look like this, and the Moon's mass in standard form will look like this. We can line these up and subtract them using our normal methods. This would be our answer. And we could convert this back into scientific notation, and we would get that the difference is about 5.8965 times 10 to the 24th kilograms. But that's a lot of work. You're going to have a possibility in a lot of places of making a mistake if you don't have enough zeros, if you don't line it up just right, if you don't convert it back properly. There's a lot of places that you can go wrong here. So this is problematic because it takes time and you need to make sure everything is lined up correctly. You need to get the right zeros, you need to line them up, everything, you have to make sure it's done correctly. Or we can do it similar to adding. We'll write the masses using the same power of 10 and then subtract. Because the mass of Earth is larger, that's the one we're going to change. So instead of to the 24th power, we're going to factor out a 10 squared, because that'll bring it down to 22, which was the power on the mass for the moon. Now we can take 5.97 times 10 squared, which is 100. So times 100, we get 597 times 10 to the 22nd. Now that we have them both as 10 to the 22nd, we can regroup them just like we did with addition, and then we're simply going to do 597 minus 7.35. When we do that, we get 589.65 times 10 to the 22nd. Now we just have to move that decimal over 2 to put it back in scientific notation, and because we move it to the left 2, we'll move the exponent up 2, so from 22 to 24. So now we have properly rewritten this in scientific notation, and while this might look like more work, you are going to have a lot less room for errors or mistakes than if you did it the other way. So this makes it more efficient and limits the amount of mistakes you could possibly make. The difference is the same. It is about 10 or 5.8965 times 10 to the 24th power. You try. The planet Venus is on average 2.5 times 10 to the 7th kilometers from Earth. The planet Mars is on average 2.25 times 10 to the 8th kilometers from Earth. When Venus, Earth, and Mars are aligned, what is the average distance from Venus to Mars? So you can see there's already some set up here. They've taken the 2.25 times 10 to the 8th. That's the bigger power, so we want to change it to a power of 7. So how do you do that? When you simplify those two parts, what do you get? So what are we adding with 2.5? We're going to add it, get our answer, and then change it back into scientific notation. So go ahead and give this a try, pause the video, and press play when you're ready to see the answer. So with this problem, we'll split up 10 to the 1st and 10 to the 7th. 2.25 times 10 is 22.5. So that'll be the number we used and add to 2.5. When we add those, we get 25. So to rewrite that in proper scientific notation, we want to have 2.5, and then we will increase the power on 10 back up to 8. To summarize, options with very large or very small numbers can be carried out efficiently using scientific notation. The properties of exponents still apply when carrying out these operations. So we're able to split things up because we know that 3 and 6 add up to 9. So we are still using our product of powers property as we rearrange these and make them work for us. Your next steps are to submit your 9.4a notes, do your 9.4a practice, and take the 9.4a mastery check. I will see you in the second half of this lesson. Good luck.